All right, so now we're going to go over the second part. We're on page 3 of lesson 11. We're going to go over adding and subtracting functions and what the consequences will be for the domain. So whenever you add or subtract a function, the resulting domain will be the intersection of the two parent functions' domain. So let's look at, as it says right here, so let's look at this first example. I've got 1 over x, and I've got the square root of 1 minus x, and we are doing this. Now it's worth noting, this is not f plus g multiplied by x. This is a notation. We were saying, whenever you see this, we're saying it's really f of x plus g of x. And so f plus g of x, right? Maybe we should write that out. I want you to write this out in your paper. F of g of x, right? That's how it should be said. F of g of x. And that is the same thing as f of x plus g of x. And f of x, well, that's just that right there, 1 over x. And then g of x is just the square root of 1 minus x. And so note the domain of f, well, everything except for 0, right? So we'll just write x can't be 0. And over here, right, 1 minus x must be equal to or greater than 0, because we can take the square root of 0, but we cannot take the square root of a negative number. Solving this for x, we find that x must be equal to or less than 1, right? And so, for our domain, let me draw better than that. There we go. For our domain, we've got 0, that's out. And then we go over to 1. And we got to be equal to or less than 1, so we include that point. Go to the left, skip over 0, and then continue. And so the domain of f plus g, as I said before, it's really the domain of f where it intersects with the domain of g, right? Because the domain of f is all real numbers except for 0. So the intersection is what I've drawn in here. And that goes from negative infinity to 0, open parentheses, union, open parentheses, 0 to 1. And we close that bracket because it's a closed circle right there. That is our domain. And this is our function. Okay? So everyone should be very comfortable with what we just went over. Let's go ahead and move forward. This time, we've got f minus g of x. Okay? And I'm sorry, I said f of g. I should have said f plus, so let's erase that. F plus g of x. F of g of x is something different that we're going to be going over later in the handout. All right, so right here, again, this is f minus g of x, right? That's how you read that. F minus g of x. And so we have somewhat similar to what we're functions that we're doing before, but they are different. So f minus g of x, again, that is simply f of x minus g of x. And so we have 1 over x minus 5 plus 1 over x. So note 1 over x minus 1 over x, that is 0. So what we're left with is going to be negative 5. And it's very tempting to just write that out as negative 5. But note the domain is going to be the overlapping of the two parent functions domain. f could not be 0, and neither could g. But the 1 over x term dropped out when we added them together. So we need to include a little line here. This line means such that. That's what that line means. And so we'd say such that x does not equal 0. Because when we write -5, this is just a shortcut. So we can calculate f minus g a little bit faster without having to first calculate f and then calculate g and then subtract the two together. But if you don't account for the fact that you couldn't divide by 0 here and here, well then, and you just write -5, you'll get an incorrect answer. And if you were to graph y equals f minus g of x, 4, 5, there we go. You would put a big circle right there to show that you are not including that point. And again, this is the graph, y equals f minus g of x, and which is the same thing as -5, such that x does not equal 0. Okay. And so our domain explicitly is f minus g, -infinity to 0, union 0 to infinity. And that is our answer for that. So again, as I was telling you verbally, note that the resulting expression is a shortcut of convenience. You must respect the path x took to get to that expression, right? Because, f and g, right? 1 over x dropped out of the equation, but you still couldn't divide by 0 even though they dropped out of the equation. So you must respect the path x took to get to that expression by stating appropriate domain restrictions. Okay, and that is very important. All right, so now we're going to go over multiplying and dividing functions. So the resulting domain will be the intersection of the two parent functions' domain, just as before, plus any new domain restrictions that may arise. So first, let's look at f times g of x, right? F times g of x is how you would read that. And note that's just a small multiplication dot, not a circle or anything like that. That distinction will become important. And so this is simply the same as f of x times g of x. And f of x is 1 over x. G of x is x squared. Note that f of x does have a domain restriction that x cannot be 0. Right, x squared divided by x is x, but we got to include that domain restriction that x cannot be 0. And so, if you were to graph this, it would simply be the line y equals x, but it could not go through the origin. And so the domain of f times g is all real numbers except for 0, which we express in interval notation like so. All right, moving on. This time, f is x squared plus 3x. G of x is x. And we're not doing multiplication anymore. Now we're doing division. Now, division is going to be, we're going to have to do one extra thing. G, the bottom function, cannot equal 0. So note that g of x is simply x. And so we're going to have to remember that as a consequence of this, x cannot be 0 either. It won't always be 0 for x. It'll be other numbers, but it's just been working out that way for the examples we've been working on. So again, f over g of x, or f divided by g of x, which is the same as f of x divided by g of x. And so we've got x squared plus 3x divided by x. Note I can factor an x out of the top. And so here, x divided by x is 1, leaving us with x plus 3, but not so fast. We have to write that x cannot be 0. And our domain for this one would be all real numbers except for 0. It would be the same as what we had before. So again, note that the resulting function that ends up in the denominator, g of x in this case, cannot equal 0. Okay. And that's because g of x is in the bottom of the equation.